So we'll start with integration. So what is integration? We have been studying this a lot since you must have studied in 11th 12th, right? So integration nothing, so all these are mathematical tools which will help us solve real world problems, like it's like addition, subtraction, right? Integration is nothing but this is a mathematical tool to find area under the curve. Okay, to find area under the curve. So let's understand it quickly. So I'll give you two simple examples and then you will get the hang of it. Say for example you have one. So let me draw the coordinate axis, then it will make more sense for you. So for example I have 1 2 3, this is 3 2 1 and 1 2 3 4, like that. Okay, so we have this. So this is so we have a point here. Okay, and let's draw a triangle. So this is a triangle. Okay, let's name it ABC. Okay, so this is your origin. So this is B, this is C. So now if I have to find the area of this triangle ABC, how will you find? We know this already. So this is your area of this triangle is triangle ABC is equal to half into base into height. Simple mathematically, we know this. This is your half into base is 3 into 4. So this will be equal to like 6 units, this whole area. Okay, now again if we know derivatives will come later, right? So if we make this solve the same thing using integration, so the integration formula for basic thing like integration of, okay, x to the power n dx, this is given by x to the power n plus 1 divided by n plus 1 plus c. We'll ignore this constant for now. So this constant we'll ignore. So we'll only focus on this. This is the basic formula we remember for calculus. This for integration. So if we have xn, similarly for log x, sin x, everything will have a different formula. But this is the most common format we'll discuss to understand the concept. So for xn, this is the formula. We increase the power of 1 and we divide it by the same power, increased power. It's the opposite of derivative. So integration is nothing but summation. So what do we do? Say for example, if I cut this triangle into very small strips, very small strips, very thin strips, very thin, okay, and I add all those thin strips together, then I can get the area of that triangle. That's what integration. The dx is like a very thin strip, and if I know the equation of it, if I move along the equation of this line, okay, so let's change this a bit. So this is to make it simpler, so this, so we'll make it, so this is your 1 2 3. So the equation I'm just making it simple, so the concept remains the same. Sorry, let it be on this point 3 comma 3. Okay, and this is your triangle 1. This is our triangle. Okay, so now what's the area of the triangle? Half into base into height, that is equal to half into 3 into 3, that is equal to 4.5, 9 by 2. Okay, and now if you say this equation of this line, right, this equation, this is nothing but y is equal to x. Here x11 y, x1 y1, x2 y2, and I have taken purposefully so that it simplifies. Okay, so let's quickly understand. So if, so now we know that y, my f of x, okay, is equal to x, y is equal to f, y is equal to x, we can write like this. And if I integrate this, okay, if I integrate f of x dx, my area, I can write my area of triangle as integral f of x dx. Okay, and what will be the range of integration from here to here, from 0 to 3. So I know the equation of this curve here, sorry, this is y equal to x, I'll just put it here. So this will be equal to x dx, and what's the range? From 0 to 3. So x is changing from 0 to 3, and for y how much is it changing? I have the equation, that is the bound of this, how x is moving, and dx are these thin strips which I'll be adding. So integration nothing but addition, so I'll be adding all through the equation of the line. That's what it means. So it gives me the area under the curve, and the curve is this here, y is equal to x, and I will just move along the curve and I'll take thin strips, and finally I'll get the area of whatever region. So from here, this triangle is from 0 to 3. If it was 4 4, then this will be a bigger triangle. Right here the area will increase. You can just keep on increasing the area of the triangle like this, and I'll get the area of the triangle below this. Okay, so what will be the equation here? So this is equal to integration of x dx is x square by 2, and the range is from 0 to 3. So this is your upper limit minus lower limit. So 3 square is 9 by 2 minus 0 by 2. So this is equal to 4.5. Same as what we got from half base side. Okay, simple. Let's do one more example quickly so that it solidifies your concept. So we have another example. Say for example, we have a rectangle this time. So 1 2 3 4 5 6, something like this. Okay, 1 2 3 4, 1 2 3 4 5, like this. So this is your y x 0. So that's why coordinate is very important to understand. And we have say equation, so say for example I have a rectangle here from here to here. So I form a quadrilateral, a rectangle, right, ABCD, like this, and the area here is this area. I want to find this area. So we know the area simply. Area for this simple thing is just length into breadth. Length into breadth is, length is here 5 minus 1 4, and the breadth is this is length, this is breadth, so 3. This is equal to 4 into 3. This is equal to 12 units, whatever is the unit. Similarly, if I want to find this area of ABCD, whatever is the quadrilateral, okay, this will be equal to integral. So what is the area under the curve? So this is the line here, and I have to find the area. So this is the line and I have to find the area under the curve for this. So this is changing, y is changing here, and x is here, and I will take thin strips like this along the axis. I'll move along the axis, keep on taking very dx is like delta x tend to 0, very small strips, and I'll integrate it like this, all of them, add all of them, addition, integration, nothing but addition. So what will be the equation? What is the equation of this line? The equation of this line is y is equal to 3, right? So my fx is fx dx from range 1 to 5. This is there. So this is equal to integration of 1 to 5. Fx is my fx, f of x is equal to y is equal to 3. That is my function of x, right? So this is your 3 dx. This is nothing but, what is integration of constant? That's 1. So you increase the power by 1, right? X to the power n plus 1. So I can write 1 as x to the power 0, increase the power, x to the power 1 divided by 1. So finally it will become x. So this will be 3x from the range 1 to 5. So this is equal to 3 into 3 outside, x will be upper limit minus lower limit. So that is equal to 3 into 4 is equal to 12. Now I will say, what's the point? I can do it simply like this. So why am I going this way? So this is just to make you understand that that integration is nothing but your area under the curve. If you know the equation of the line or the curve, here this is a line here for 2D, that's the simplest. Here this was y equal to x, and here this is y equal to 3, that is my function of x. But what if my equation, okay, the line's equation is a bit different? Say for example, if I have a curve, for example 3, I have an equation like y is equal to x square. This is my fx. My fx is equal to y is equal to x square. This is my function. So what will be the curve look like? So y is equal to x square. This is a quadratic. So this will be a parabola, downward parabola. So this will be like this, something like this. Something like this. The drawing is not accurate, but I hope you get it. Is your y is equal to x square. Now do you have any formula for calculating the area for this? So you had this simple formula, so you said what's the need. But do we have any formula for calculating area of this thing now? If I want to calculate, say for example, these units are 1, 2, 3 like this here, and here 1, minus 1, 1, 2, 3, minus 2, minus 3 like this. And if I want to calculate the area of this between these 2 points, say from here minus 2 to 2, okay, say, so I'll just color it off, say from here, okay, this area from between minus 2 to 2, I want to calculate only this area. Do we have any ready-made formula for this? No, right? So that's why. So now that's the beauty of calculus. Now you have the area of the curve, and now you can just simply put the integral formula and get the area. What will be the area for this? So my fx is equal to y is equal to x square, and I want to integrate this. So my area will be equal to integral minus 2 to 2, from minus 2 to 2. I want to, this is my x-axis from which I want to integrate, and equation x squared dx. So this is equal to integral of x cubed by 3 from minus 2 to 2. So this will be equal to 1 by 3, I'll keep outside. This will be x cube minus 3. So this will be 2 cube minus of minus 2 cube. So this will be equal to 1 by 3, 8 plus 8. That is equal to 16 by 3 units, whatever is units. I hope this makes sense now. This is the whole. So that's how we can calculate the area of a Gaussian also. So this is a Gaussian, right? We have done a lot of PDF. So if I know the PDF of this curve, I can integrate from whichever region to whichever region, and then I can get the area under the curve for getting the probability in this range. We know, right? From 1 standard deviation to minus 1 standard deviation, the area under the curve is 68%. So if I apply the Gaussian PDF formula, e to the power minus x minus mu whole square by 2 sigma square divided by 1 by root by 2 pi sigma. If I integrate it from plus minus 1 standard deviation, that is plus minus sigma, minus sigma to plus sigma, integrate this minus sigma to plus sigma, I will get this 68.4. Okay, and that's the whole use. Why did I say? So integration, I hope that integration is clear.